Okay, we'll go ahead and get started here. Matt Mayernik works at the NCAR library as a project scientist. In the library, he leads all initiatives related to scientific data services, including ongoing projects focused on data curation, metadata practices and standards, and data citation. He received his PhD from the UCLA Department of Information Studies in 2011 and is a current member of the board on data stewardship within the American Meteorological Society. I'd also mention my own editorial. When Matt first arrived at NCAR, he led the initiative for deploying and implementing digital object identifiers at UCAR. It was quite a task, and also was the primary author of the white paper on that subject, which has gotten a lot of references. So with that, I'll introduce Matt.
Great. Thanks, Mike, and thanks to all of you for coming. It's nice to be here to talk about this project, and Mike is a co-PI in the project, and a couple folks in the room here have been involved. This is a partnership between NCAR, both EOL and the NCAR library, and Cornell University and UNAVCO, which is another data facility just down the road here. Some of you might be familiar with UNAVCO. So I'm going to kind of talk about this project. It's been going on for a few years, and we've been doing quite a few things, and I just wanted to give you an update of where we are. Just to kind of give you the end of the story first, what we've been working towards are two systems to manage and sort of display information related to field projects. With EOL, the Arctic Data Connect system, and then Connect UNAVCO, and I'll be showing demos of these, but I just kind of wanted to give you a preview of where we're going. And so this is going to be, like I said, kind of a bit of presentation before a demo to give you an idea of why we're doing this project, kind of what we're trying to do, what we're trying to accomplish, a little bit about the technology. It's not a technology-intensive talk, but I'll give you a bit of background on some of the key details, and then a few demos of those systems that I mentioned, and then talk about sort of what we think we've gotten out of the project in terms of what we learned and hopefully where we're going with this. So one piece of background that's necessary for this talk is just to give you a quick explanation of the EarthCube project or program within the NSF. How many of you are familiar with EarthCube? Just out of curiosity? Okay, so most of you are, so I won't have to say a whole lot. But just to cover a few bases, it's a kind of a combination of technology funding and community development program within NSF focused on cyber infrastructure for the geosciences. And there's a lot of things that have been done under that umbrella, but generally sort of the focuses are facilitating data sharing or sort of knowledge sharing around geoscience data, and then interoperability and integration of data and tools within and across domains. So the sort of cross-disciplinary idea has really been a strong push in EarthCube, which is important to our project as well. Like I said, it's both community and technology development. So our project is kind of taking off on a couple of aspects of that sort of EarthCube vision. The first sort of motivation for why we started this project was, as you and EOL certainly know very well, a lot of scientific projects, especially field projects, are quite large, quite extensive in terms of the partners, in terms of the organizations that are involved, distributed across the country perhaps, and so sort of have a virtual community, so to speak, distributed participants who use communication in virtual ways, and then information and sort of product sharing that is also distributed. So you guys manage lots of collections of materials, but there's also lots of things that are outside of what EOL manages in many of these projects. And so there's occasionally issues of duplication of information or disconnect of information across these various participants in some projects. And so what we wanted to do was build systems that support heterogeneous and distributed projects in terms of information management and connection. So to give a kind of quick example, you might not be able to read all the details, but they're not specifically that important. This is a list of kind of projects under one of the programs that is involved in our project called the Bering Sea Project, which EOL has been involved with or was involved with in the past. So there are quite a few different components to the projects, some around plankton, some around biophysical, et cetera, lots of different PIs. So this is a list of sort of projects. And this is on the Bering Sea Project website outside of EOL. Also on that website, you can find a list of publications. And so you got authors and titles and journals and so on. And of course, if you look across these, there's a lot of people that show up in the same lists. So the authors are often the same people who are the PIs of the projects and so on. This is EOL's main component of the project, which is the data collection. And again, if you were to look at sort of these PI lists, you'd see the same names. showing up as in the publication list and the project list. But sort of before our project, all these lists were separate. So there was no connection between the data set, the publication, and the project list, at least in any sort of structured way. And so that's the kind of thing we wanted to cut across, is really sort of be able to go from one thing to another in terms of what's where the relations are from a paper to a publication, so to speak. So this is sort of the cartoon depiction of that. What we want to be able to do is to support networked science, because we know a lot of these products and people and projects are well represented online, but in some cases disconnected. So we want to sort of be able to get somebody who's interested in data to the publication, to the people, to the organization, to the projects, and sort of find what they're interested in wherever they start with in these kinds of nodes of information. So that's again, the big picture description of the project is to enable information about these distributed projects to be shared in new ways to better support this idea of networked science. So we know there's lots of stuff online. We know many things are related, but often those relations are hard to find, which I'll talk about more. But if we can find those and represent those, then there's a new way for people to find and understand the products of these complicated projects. So the two sort of use cases or community projects that are kind of our two focuses in this project, this is definitely a focused project, is within EOL, the Bering Sea project, and then UNAVCO, which is a data facility. And both of these were chosen specifically because they are interdisciplinary, multi-organizational, have lots of different products and sort of outputs from these sort of two projects. And so there's lots of things and sort of components that we could potentially think about in sort of this networked science way. So for those of you who aren't familiar with the Bering Sea project, some of you I'm sure are very familiar, it's actually, as I showed that list earlier, quite a few projects under the heading Bering Sea project. So there were two main programs, one funded by NSF and one funded by the North Pacific Research Board, that were sort of put together under this heading, Bering Sea project. And there's biology data, sort of oceans, like walruses and birds and things like that. There's oceanographic data. There's some meteorological data, and probably other things I'm not thinking of as well. UNAVCO is a facility that focuses on geodesy, which is the study of the shape of the Earth. So they have a lot of data on GPS networks. They have borehole data to study sort of the movement of the Earth. They actually have meteorological data as well, which I think a lot of people don't know. And again, in both cases, it's not just NCAR project. There are many university partners, and UNAVCO itself is kind of like NCAR. It's a community organization. So everything that UNAVCO does is with partners from their university community. So we have lots of participants and people and projects and products, and those are the kinds of things we want to try to bring together. So the technical approach, again, I'm not going to go into too much detail, but just to sort of touch on the background, is the semantic web. And semantic web is a suite of technologies that's been around for quite a while now, probably 10 or 15 years. And I think it's kind of turned the corner in terms of what it's really being used for in productive ways. But the basic idea is it's a machine understandable way to structure information about entities and relationships. And I'll show some kind of simple examples of this. And this idea of typed relationships. So when you're on the normal web or the internet every day, there's lots of links between things, but the links are just sort of dumb links. You don't really know why this thing is linked to whatever it's linked to, and vice versa. Once you're on the other end, you don't know why you've been linked there, at least based just on the link. And so the idea of a semantic web is that you can sort of declare some reason for that link being there. I'll show you an example of that. The good things about it, or the things that we liked about it for this project, is it's a web-native set of standards. So it was developed by the W3C, which is the same organization that developed HTML and HTTP. Tim Berners-Lee, who developed the World Wide Web, is also the developer of the Semantic Web. So it's not just sort of a boutique thing. There's a lot of imprimatur there. It's scalable. There's a Semantic Web slogan of the AAA. Anybody can say anything about any topic. And I'll again show an example of that. And there's a lot of applications on search is one of the main applications. So kind of a lightweight implementation of semantics these days is if you look at web search like a Google search, and there's it's called a rich snippet under your Google results. So if you get like your first page, there's a little bit of text underneath it, or sometimes on the right, if you search like today's weather, some stuff will show up on the right, like the temperature and some other information. that's a sort of a lightweight application of semantics. So even big search engines like Google and Yahoo are getting into this in some ways. So here's a simple example. Again, the main focus from a technical point of view is entities, which are representing these blue blocks here, and then relationships between them. And so the kind of benefit is you can create these chains of information. So if I have a grant, I can say this grant has an output of an article. The article has an author of some person who's the creator of a data set, and that data set may have been collected at some station. So the idea that there's these entities, and then you can add these, again, typed relationships. So you know that the relationship between this person and this data set is that this is the creator of that data set. And when you add in this sort of AAA slogan that anybody can say anything, if you then learn later on that there's another data set that this person created, you just added one more statement that says this entity that you already know about is also the creator of this other data set. And likewise, you can kind of keep adding connections as you learn more about whatever it is you're representing in your system. And so that's what we've been doing in terms of these field programs, the Bering Sea Project and the UNAVCO projects, is building out statements like this of this data set was created by this person, and so on. Like I said, I think there is sort of a turning of the corner. I think semantic web for a long time was an academic kind of thing that artificial intelligence people really loved because it had lots of logic involved. But there's a lot of practical applications in the geosciences now and data facilities. And some of these may just be slogan or logos to you, but most of these are NFSF facilities. These are oceanographic facilities. Data One is an environmental science sort of search engine. It combines data from 30-plus repositories. Oak Ridge has a semantic search tool now. LASP, right down the road, is using semantics for sort of their database. And Deep Carbon Observatory is, again, a big integrated project, 10-year project funded by the Sloan Foundation to integrate lots of information about deep carbon, which is geophysics and other things. And there's kind of three applications that tend to be used in the semantics world. There's search, like I mentioned before, provenance tracking. So if you go back to this example, you can kind of see how sort of knowing these connections is naturally lends itself to tracking provenance of things. And then metadata management. So in this case, their whole metadata store is based in the semantic model. In the atmospheric sciences, there are a couple of applications as well. I think it's maybe not quite as widely deployed, but a couple of interesting ones that I thought I'd mention are, this is the National Climate Assessment Report from, I think, 2015, the previous one. And so this comes out of the U.S. Global Change Research Program. And this is, I think, a 1,000-plus page document with lots and lots of information. And to support the writing of this report and the presentation of this report to the public, the US GCRP used a semantic database to track everything that went into this. Every author, every publication that was used as a reference, which of course there were thousands, every data set that was referenced, and then the connection between those, every chapter, every figure, literally every sort of figure that was shown has sort of a semantic-based provenance tracking of where the data came from. And it's all open and online. You can query it. So that's, I think, a really interesting example. Another one, which is a bit more nascent but might become a bit more visible going forward, is there's a new initiative in the NetCDF world called NetCDF LD, which is linked data. Linked data is just kind of a particular application of semantic web. And the idea there, and some Unidata folks are involved, but it's being led by folks outside of Unidata, is to try to get some of this idea of these semantic representations into the NetCDF data structure. So it's just a way of working within NetCDF to represent some of those links and things that I showed in my example. So within our project, we're using, as best as we can, a methodology that comes out of RPI. Some researchers there that have used it quite a bit, called the Semantic Web Methodology. And it's really a use case-focused methodology. So the idea is you start with some particular use case that you're trying to solve. And then from there, you develop kind of what you want to do, the ontology, which is the sort of technical representation of those links and relationships, and then your tools and sort of technology and prototyping and kind of iterating from there. So within our project, we did a couple of activities to develop use cases. The first one was focused on the data centers. So that's here at NCAR, EOL, and at UNAVCO. And that was to come up with use cases kind of like this. So the things that we would like the system to be able to support is the idea behind a use case. So finding publications and or other products that use GPS data held by UNAVCO. So that's kind of a fairly straightforward way of describing something that we want people to be able to do. Identifying, in the case of EOL, identifying people who collected specific Bering Sea data set. So again, that's kind of a very specific use case, but something that we can implement towards. And then there's lots of permutations of this. So, identify people based on data, identify publications based on data. It's all about those, the networked idea that there's lots of connections, and sort of wherever you are in that network, you can get to other places in that network. We also did a use case activity with some scientists from both of these communities to kind of get that perspective on what would they like to do with a system like this. And so a couple of different types of cases came out. The first one is looking at sort of geospatial regions. We haven't done a whole lot with this use case, but I wanted to put it up anyway because I think it's an interesting set of cases. So these are the sort of specific questions that the scientists came up with. So where are the areas in a defined region where benthic biomass is high and is a line between benthic and pelagic dominated ecosystem shifting? So this has to do with biomass in the sea. And so if you sort of extrapolate that, what they're asking for is something like a geospatial region where data have specific features. So where benthic biomass is high, for example. And we probably can't directly answer these questions with our systems, but what we're at least hoping for is that they could find data that could help them answer these systems. And so the other one, which was about specific events or locations. So if you know of a hurricane or an earthquake, can you find information that took place around that time in the same location? A slightly different one was if you're doing a new field project and you want to know who's done work in that area, both from a scientific perspective, but also from just a project management perspective. You might need to get permits, or you might need to find a local community who can help you out with installation of some kind of equipment. And so even if somebody's been doing some work that's sort of outside of your topic domain, it still might be good to know about that. So again, it's kind of a use case that came out. So the use of these use cases is in helping us sort of identify particular things that we're interested in. So publications, defined regions, data sets, things that we can then represent in our system. The technology we're using is called VIVO. It's an open source application. It's probably about 10 years old now. And the main use case for VIVO is, and I'll show an example of this when I do the demo, is faculty information pages at a university. And this was what it was originally developed for. And the idea is, if you have a large research university, you've got information in lots of different databases across campus about people, maybe what classes are being taught, what grants are being received, what publications have been written by the faculty members, and they're all kind of separate. And so VIVO was created to sort of have one place that this information could be put together. There are quite a few uses of VIVO, or users, I should say. They have their own conference. Just last week, Brooks from EOL was there. Some of you, I'm sure, know him. And it uses this semantic approach. And the basic structure of it is there's a sort of front-end user interface, which I'll show some examples of. And that's based on this data store, which is in the semantic model. And sort of you have your various data sources, and you do your mappings to put them together. And there's no sort of magic in this mapping step. Can take a lot of work to integrate. What's the connection between that data source and that data source. But having the underlying data representation based on those use cases can help you identify which connections you want to make between, say, your publication list and your data set list. So again, I'll show a couple of cases so you can see exactly what this looks like in just a minute here. Just to describe quickly what we were doing that's different from the standard use case, the standard use case being sort of a faculty information system on a campus, is first of all describing different kinds of information. So we have different information than you would have at a university. So we have ships, networks, platforms, data sets, right, things that earth science and geoscience focused. And then also, as I said at the beginning, with these distributed projects, we have a very different use case in terms of where the people are. So if you're at a university, you know everything there is to know, well, at least what they can tell you about your faculty members. But if we're based at NCAR, we don't maybe know a whole lot about the PIs who were involved in the field program, besides that they were involved in this field program and that they were involved in a data set collection. So again, some of those use cases that I showed earlier directly relate to these sort of differences that we're, or these customizations that we're adding into VIVO. So now I'm going to see if I can pull up some demos here. The first thing I'm going to show is actually the Cornell University VIVO instance. Cornell was where VIVO was created, so it's been about 10 years, I think, in development. And I think it's a good example of sort of standard VIVO deployment, just to kind of give you an idea of what it looks like, kind of look and feel. And since they've been doing a lot of development, it's quite large and has a lot of information in it. So the basic idea is you have, again, sort of some key entities represented by these tabs along top. So you might have lists of people, which you can sort of see here. Might be faculty members, other kinds of types of people. And so you can add sort of particular types of people. You can classify people by their categories. This is just showing faculty members within the organization. Or Cornell University, you're going to have lots of different types of organizations, schools, departments, libraries, centers, and so on. And each one of these you could then click on and get more information. I'll show you a few in a minute. Within the research sort of section, this is information, again, about sort of more products, papers, posters, grants, and there's quite a few of these in here. And then events, and that's something that I think is maybe a customization for Cornell, but conferences, talks, so things that you would see on a campus, as you might expect there. I'm going to show one person profile. Matt Pritchard is a scientist. He's a geophysicist based at Cornell. He's involved in a lot of UNAVCO projects, which is why we're working with him. He's actually a member of our project's advisory board. So, sorry, I'm going to skip through here to his full profile. And so what you're seeing here is kind of all the information that they have in this system about this person. And so again, a lot of this information is probably coming from different sources around campus, and that's kind of again, VIVO as the integration point is one of the main benefits. And then each one of these links, which I'll show here, is itself a node in that network, the networked information model. So I'll go through a few, but if you wanted more information about any one of these entities, you just click on that and you can get through there. So at the top we have basic information about this person, and then if I go down, there's information about sort of a bunch of categories here. So he's a member of this field, he's a member of a particular program, whatever that one is up there. He's got lots of grants, articles, let's see, conference papers, teaching. And so again, these are probably all coming from different databases around campus. His background, his awards, and then down here some information about his email and so on. So just to kind of start moving through this sort of network idea, just click on the first article. So this then gives a bit more information about that article. And so again, it's sort of a profile page for an article. So we were looking at a profile page for a person, now we've got an article. So a few more authors, journal, publication date, and I can keep then sort of going through this chain. So if I'm interested in this journal, I now have the sort of profile page, so to speak, for that journal. And these are all the papers published by Cornell authors within this one journal. Or if I was to go back and go back to his profile page and choose a grant, I can get more information about this one grant. And so each one of these, again, is a node in the network. If I want to see what all the geoscience directorate is funded at Cornell, I can click on this. There's information about the geoscience directorate and all the different grants that they've funded. So the sort of idea of being able to sort of chain through these different representations or these different entities, and kind of as you're interested in, is kind of the idea. So if I just kind of click one by sort of by random there, there's another one, there's another faculty member. So if I was interested in Hawaii, for example, who works in Hawaii, I could kind of go there and keep looking. So wherever you're interested, and you kind of follow these chains, and you can also search as I showed up above. So that's the basic idea of VIVO. And now I'm going to move more into the two systems that we've been working on. First, Arctic Data Connects, based here at EOL. So you see the same basic structure here on top: people, organizations, research, and these. If there were other entities, which I'll show in the NAVCO case, you could add those. I'm going to jump down here to data sets, which is one of the extensions that we've done. So here's the full list of data sets from the Bering Sea project. And again, this is a heterogeneous set of programs underneath this one named Bering Sea project. So there's the list of data sets, and now I can start digging in. So I'll just choose this one. So here's the kind of profile page, so to speak, for the data set. Now what this is doing is pulling a lot of information from the MDAC, the EOL metadata database. And so this is not showing the actual, or doesn't hold the actual data set. It's a discovery service. So if you actually want to get to the data, it's linked right there from the profile page, which with a lot of the same information. But what I wanted to show is, again, kind of being able to go through these links down here. So this is that Bering Sea data set. If I click on the model page, or the model link here, it's a subject area. Now I've got a list of all the data sets within this program, or this project, that are model-based data sets, or have some relation to models. So if I wanted to look at hindcasting or something, I could dig in from there. So that's one of the ideas we can dig into here. Just keep going down. Here's the DOIs. Mike mentioned at the beginning, all these data sets have DOIs now. Source platform. So this gets some more information about what kind of instrumentation, or in this case a platform, was used on this particular data set. So snow depth. In this case, there's just one data set, the one we were just looking at, that has this platform. And so this is, I think, a good example of using the semantic approach to winnow down to a very particular thing. And so if I was interested in snow depth, and I was sort of following it in this way, I'd get down to this is the data set that I should be looking at. There isn't a huge other list of, or a huge set of data that I'm somehow missing because I'm not finding it. So the snow depth sort of semantics helps me really sort of zero in this case. Again, there's people, there's contact points. So I'll just choose this person, and now we're at a person profile. So just like we were showing in the case of the Cornell researcher. So a little bit of information. Obviously, we don't have near as much, and that's one of the challenges of what we're doing, is we don't know a whole lot about a lot of these PIs. We've had to spend a little bit of time finding even emails and stuff like that. But we do have some information, and we have a lot of information about publications and data sets that this person's produced in relation to the Bering Sea project. So this is not the full list of this person's publications, and that's not intended to be. It's just in relation to the Bering Sea project. This is what this person has produced. So again, that use case of being able to find people related to data sets, this is kind of how we would support that. We can also do searching as well. There's a search page up here. I'll search on more of a topic in this case instead of a person. And so when I search on the topic benthic, which again is related to biomass in the sea, we get some people, some activities, and a bunch of research products. So this is a way of zeroing in on some of those if I wanted to select by sort of those kinds of entities. I'm going to choose this first data set here, show another data set page. So again, there's information. If I was to link out to the actual data delivery page, I could do it there. Information about the dates, more subject areas, skip down there. The thing I wanted to show on this one is at the bottom here. So there's some information about people, so a bit more detail about the people, not that they're just sort of an author, but they were originator or principal investigator. So again, a bit more detail on a person, what their role was, and then instruments. So again, this is definitely a sort of step beyond what you would see at the Cornell site in terms of information about what a person has done. And so now if I want all the data sets that were in this collection that use this instrumentation, I've now been able to sort of dig down into that. So that's the kind of value add of this approach, is being able to follow those chains, sort of winnow search or your sort of browse down by these particular entity types and relationship types. Any questions at this point? So Connect UNAVCO is doing a lot of the same things. They've done some customizations in terms of the display. You can kind of just see from the very beginning here. But again, a lot of the same kind of tabs on top. A couple things I wanted to show that they've done in addition to what I showed before. Just as a quick example, they did a community survey of the UNAVCO university community, university members, and I think some associated members of the community about expertise and topic domain expertise. So obviously there's a lot of people who sort of reported that they're interested in geodesy because that's what the facility does. But you can kind of dig down here, and I don't know what some of these are, but I think they're software packages, and if you're in this community, you probably would know. But I just wanted to sort of show the meteorology one. So this is a profile page for meteorology, anybody or anything in their system that's related to meteorology. So they have some academic departments and some individual people. So if you were working in the meteorological space and you wanted some help with perhaps GPS networks or geodesy type topics, these would be the people you could talk to. And there's a software engineer at UNAVCO who might be able to help you with these kinds of things. So again, sort of winnowing down by particular entities. The other thing that I'll show that I think is an interesting customization that UNAVCO has done is places. So UNAVCO's work, especially their GPS networks, is all stations, GPS stations. So they have, I think, 3,000 stations around the world with GPS stations around the world. And so they've developed this sort of search mechanism to be able to find stations. And then you can see kind of these links. They're all sort of connected to different people and places and so on. And I just wanted to, I was looking around earlier and thought I found one that was kind of interesting. Colorado. This one called NCAR. Yeah. And so again, this is not their data access system, so you could link out to actually get the data for this station. But they've put a little map there. You can see it's got a little bit of geographic nesting. And then John Braun, some of you might recognize that name. He's a cosmic researcher. So this is some kind of station that John Braun is associated with. And so there's a little bit of information. And if I actually want the data, I can click on here, and I can get the data, sort of just like I was showing with the EOL example. And if I want, just more information about John Braun, here's the information they have about him. So he's a member of this working group. He's got some abstracts and publications. And this is something that's also built into the most recent version of VIVO. So the EOL case has this, or the EOL system has this too, for publications that actually have altmetrics. What this is showing is sort of some visualization of altmetrics, which is sort of social media activity. Most of these are pretty low, so it's been tweeted by 4 people. This one is gotten a bit of news since it was about the United States and Cuba. BAM's article, so that one's gotten a bit more uptake. I don't know what the numbers is. I think it's some sort of calculation based on some of these things. But so the VIVO program has a lot of these things starting to be built in. So once you input a publication, this is just sort of built into the system. So let's see. So I'm going to skip that part of the demo. So that's the basic idea. Is we've got lots of information. We're trying to bring it together to allow people to make connections and sort of follow those connections based on their interest or based on a question or what have you. Any questions about those demos before I keep going? So the one other thing that I'm not going to show a demo of, but I just wanted to mention briefly is because we are focusing on, in our project, systems that are representing people from outside of NCAR or outside of UNAVCO, there are people who are working at universities that also have a VIVO instance. So, like, for example, at Cornell, I showed Matt Pritchard, a scientist at Cornell. He also works a lot with UNAVCO. And so a feature that we're working on is still a bit, developmental, I guess, is to be able to exchange information dynamically between profiles. So if I know that there's a person, Matt Pritchard, who I know is the same person at Cornell, I could sort of send them information about that I know about him that, say, Cornell doesn't know, and I can get information from Cornell that I don't know. And so what we've really been looking at is, say, in the case of UNAVCO, they're the authoritative source of data sets that Matt Pritchard has produced in the UNAVCO context, whereas Cornell might be the authoritative source for publications or for his email address or for things that are very specific to Cornell, like his academic rank and so on. And so we're developing a sort of lookup feature that would pull dynamically information across. I'm not going to go any more into detail on that, but it's we've done some pilot demonstrations. We know it works. We're still working on some bugs. So that's the idea. Is there's lots of things out there in the web world, and we're trying to kind of cut across some of these boundaries between resources and products and so on. Say a few things about some of the things we've learned and some of the, I think, challenges we've run into in this project. So one thing that's definitely true, and this is not specific to EOL, this is definitely true for anybody who's using VIVO or a similar system, is that you're constrained by what information you have. The information about a link between a data set and a publication doesn't just sort of pop out of nowhere. You have to find that information if you don't know it. And I'll show an example of that in a second. So if you don't know information about, say, subject areas or instrumentation, you can't add that into your system, obviously. And so we've had to sort of tack back and forth between what would we like to represent for the use cases and what do we have in our systems that we can represent towards those use cases. And so you just may not have some kinds of information that even though you would like to have it. And this is what I just said, identifying relationships that can be particularly hard. Here's an example of this. So this is a publication related to the Bering Sea, and I think this was from that list of publications I showed at the beginning of the project. So we know it says the Bering Sea Ecosystem Study down here, which is one of the components of the Bering Sea project. And some of these PIs, again, are people that are definitely PIs of the Bering Sea project. So we know this is a relevant and related publication, and this is represented in the EOL system. Somewhere in the middle of the paper, it's got a methods section, and it describes a lot of measurements, when they were taken, sort of what the vessel was, when the dates were. So we have a lot of information in the publication about the data. And there's also in the acknowledgments the Healy POS MV data, which is a sort of position, sort of navigational data for the ship, was provided by NCAR EOL. So we know they use NCAR EOL data. We know they used Bering Sea data, but it's hard to then go from this to what EOL has and sort of say, well, which of the 5 different POS MV data sets did they use, or did they use all of them? So just because you have this doesn't mean you can necessarily represent it concretely based on the information you have about the data sets. So that's, I think, an ongoing challenge for this, is especially looking backwards in time. How people reference data was very, I guess, idiosyncratic. So that's where Mike mentioned the DOIs, really sort of promoting DOIs. And the DOIs for data sets and other things are really kind of key sort of integration points for this approach that we're working on now and that others are working on in the semantic web context. So if you can discretely identify, so instead of saying the Healy POS MF data, if they would have said the Healy POS MF data DOI such and such, we would have been able to very directly make that relationship. Although I should say that in their defense, the DOIs for this data set were not created when they had made this publication. So that's one of the timeline issues with this case. But there's also ORCIDs. ORCID is a person identifier. And it's kind of the same idea. If you can uniquely identify yourself as a person, you can your information can be cut across these various systems. And sometimes that's good. Sometimes we may not want our information to be integrated. But in most scholarly contexts, that's generally a good thing. Just out of curiosity, how many people have ORCIDs? Okay, about half. So some publishers are now requiring ORCIDs when you submit a paper. Certainly not all. And it's possible AGU. Is AGU? Do you know?
It's supposed to.
So AGU might be one that's either now or will be shortly requiring ORCIDs for all authors. Software as well. There's now a GitHub plugin or export for GitHub repositories to export to the Zenodo repository, which is based at the CERN High Energy Physics facility in Europe. They have a ton of storage space, so they just say, dump some stuff in our servers and we'll give you a DOI. So there's a lot of people taking advantage of that. And so that idea of unique identification is really kind of key to what we're trying to do. So one other thing I wanted to mention is, in terms of challenges, is we're using open source. VIVO is open source. Some of the plugins that I showed, like the word cloud the NAPCO is using, is an open source, another sort of piece. So those are all great, but as there's more open source and more customization of open source, it can make it really hard to cut across these things, even if we think they might be able to do that. So here's an example of this. Well, one thing I didn't show, which I'll just maybe, if I can pop it up really quickly, is, so I mentioned at the beginning machine readability. So if I go back to the sediment cores example in EOL, all of these entities are also representable and represented in machine readable format. So you never want to look at this stuff, but your machine, if you were writing a program to access some of this information programmatically, it's all there. So that's great, which allows potentially queries across systems. But just to give you an example of why that can be challenging, within the VIVO world, to represent authorship, there's sort of this set of entities and relationships. There's a document, it's got a relationship, it's got an authorship sort of entity, there's then an agent, which might be a person, and then sort of the name. So if you wanted the name of the author of this paper, you'd kind of have to do a query that sort of followed this chain. There are other systems which are, again, out there that you could query in the geoscience world that would have a different set of relationships. And it's kind of the same, but it's, from a technical point of view, different. You have a document that has an author, a person, a family name. So it's a family name instead of just a name, which is called a label. There might be another system called qualified attribution, and this is called an attribution instead of an authorship. And so there's an agent and a person and a last name. So even though names are something that have been around forever, and any system that has people has some representation of names, it can be a totally different query for getting the person's name for a document across three systems that are doing very similar things. So this is an actual case of me trying to do some queries for the same person across three different systems, one of ours and two of another, two from two other organizations. So again, open source, Semantic Web, it's great, but it also means if anybody can say anything, that they probably will say anything, and there's going to be a lot of heterogeneity. So a couple, just to kind of close up here, benefits of what we think we're getting out of this project, in addition to just being able to sort of learn this technology and sort of see what it can do, is really trying to sort of support and promote this idea of a new way of doing research that sort of focuses on connections, relationships between things. So if you can understand the connections between the people and the data and the instruments, maybe have more information about the provenance, about the quality of something, as well as a way to find, say, an expert who has an expertise in instrumentation that you can take advantage of. So that's kind of the second bullet, the ability to leverage this information to do something that you might not be able to do otherwise. As we sort of work forward in the EarthCube community, we're looking for opportunities to integrate with other external partners. So another EarthCube project that is doing a semantic web approach has also a lot of ocean information. And so we did sort of some basic sort of checking, and they have information about 40 of the same people that are in Arctic Data Connects, the EOL system. So we know that there's opportunities there to connect information and exchange information that we may not know about these people that they do know, or vice versa. If they want all the information that we have about Bering Sea data sets that this person might have produced, we can provide that. And then, as Mike said at the beginning, when data DOIs are becoming more widely used, it should be easier to identify publications, hopefully, that used EOL data instrumentation, which, of course, is always good to be able to use for metrics. So I'm going to stop there. Thank Mike and other colleagues who are in the audience, and open up for any questions or comments.
Thanks. That was really interesting, Matt. You touched on this briefly, but I'm wondering if you could say a little more about what you envision for the application of this to historical versus things coming up in the future. How hard is it going to be to go to bring in historical data sets, for example?
Yeah, that's a great question, and it's I think it is a challenge, and I think it's like I said, sort of there's constraints on what you can do based on what you know, or what effort you can put in to find these links going backwards in time. So, for the most part in the EOL system, a lot of the information is coming from MDAC, but we did have a couple members of the library staff look for some of this publication information, as well as information on some of the ORCIDs that people had. So it took a little bit of time and effort to do that. So it definitely is going to be a challenge going back to really do this broadly. In separate projects, and not in this project, another library colleague, Keith Mall, who's not here, but software engineer, we're looking at trying to do some automation of detecting, say, a data set name or a facility name in publications going backwards. So we still have to find, say, publications that we think are relevant or interesting, but we could maybe run them through some text analysis to say, like I showed that example of the Healy, if it says Healy and it's talking about Bering Sea project, well, we can maybe sort of flag that as a potentially relevant paper, as opposed to one that's about, geysers in Yellowstone, is just not relevant. So there's potential for some automation of looking backwards, but it's still going to be based on entities that you think are interesting, like the Healy ship or something, or just being able to put time towards digging into it.
And the thing I would add is the MDAC database is really comprehensive in terms of the metadata that it holds, and of course we've had to add fields for new things like ORCIDs and also clean up the metadata to make sure it's consistent. So one way we're helping with this retrospective analysis and look at data sets and publications is improving that metadata database, as time goes on. But it's pretty extensive. It's got a lot of information, historical information.
Yeah.
So I was thinking about when you were talking about joining, so two different entities or two different people's ORCID IDs, and merging the information. And so I think in a lot of cases similar to that, there's the need to have a conflict resolution, like identifying false positives.
Yeah.
Could you say a little bit more about how that's handled in VIVO?
Well, there's definitely no magic sauce there. You have to either sort of tell it that this person is the same as that person. What it does have is it has a lookup capability that allows you to look up entities within your system and sort of say that this is the same as that person, or this is the same as that, whatever they are. It could be the same data or the same person. What we've done is the sort of plug-in or additional development we've done is to extend that to other VIVO implementations. So you're not just looking within yours, but you can say, look for Matt Pritchard in me and Cornell and whoever else is part of this system, and then you can say, find, okay, this person in Cornell is the one who I actually think is the same. So we're definitely limited by, you still need to know that, say there's a person at Cornell, or have some way to validate that. It doesn't automatically validate that for you, unless there was an ORCID, say, that you could do as an automatic validation. But if it's a sort of person's name, there's no automatic thing that will look at that because there could be disambiguation challenges there. Yeah.
Is there any machine learning element in that? So as you refine the metadata, that it gets better at identifying automatically different connections?
Well, it's not built in to do that. There's some research. There was a project funded by, I think, maybe even EarthCube to do. They call it co-reference resolution, which is the same thing. And I think that was based on a machine learning approach. And so if you know the publications of the person in this database and the publications of the person in this database, you can find that there's two of the same publications, which tells you this is probably the same person. So there's some work in that area. It's not built into VIVO, though.
So, Matt, if the happy day... Sorry. If the happy day ever arrived where the big publishers would allow us to do text mining, could life become easier for these kinds of projects? I mean, having watched you laboriously gather all this information, and it was a big effort.
Well, lots of people in this case,
Right.
yeah. Well, it would certainly open up opportunities. Like I mentioned, we've had this text mining project, and we've been pretty limited in terms of what we've been able to mine. So we've been using OpenSky publications, and we've been using some that I've manually gathered to try to get some corpuses that we can dig into for that project. I think for something like this, definitely if there was more open literature, there's just a lot of opportunities. Interestingly, in terms of data citation, the domains where there's more sort of empirical studies of data citation is the medical field and astronomy, because they have PubMed Central, which is an open database of NIH-funded publications. And in astronomy, they have the Astronomical Data Service, I think is ADS, which is some organization in Europe that gathers all the astronomical literature and puts it in one place. So for domains that have sort of centralized literature, the sort of text analysis that they've done is far beyond any other domain. And data citation is one of the areas that they've done that, yeah.
Do you know, for example, in, let's say, UNAFCO, how folks in UNAFCO are actually using it? Do you have, like, anecdotal stories of who and how they're using it?
We don't have, so I'll say first non-anecdotal, we haven't done a whole lot of instrumentation in terms of metrics yet. I don't know that it's built into VIVO, and I think it's possible UNAFCO has now been doing metrics, but we haven't done analysis on those. We've done a couple of focus groups with researchers actually at Cornell to talk about sort of the system and how they would use it. So we don't have a whole lot of information about sort of use at this point. That's definitely an area that we're going to focus on in the next year. But we've done some focus groups to sort of try to get an idea of sort of where they are now with this information, how their stuff is represented, how they would use that, and kind of that, gathered some of the information along those lines, yeah.
Matt, early in your talk, you mentioned some more difficult scientific questions like relating things to locations or events or geospatial areas. How do you see this? That's a real expansion problem. Is that something that's going to always be kind of beyond this, or is it something that, how would you expand that? Because you always need more metadata than you have, and that's obviously a big effort to go and collect that.
It might be in this case. I think the location information is something that potentially could be added in a bit more easily. At least in the case of the Bering Sea project, they have the, say, ship track data. So we haven't added that into the system yet. And there's actually a lot of sort of semantic work on geospatial representation, and we looked at it a few times and kind of got focused on things like datasets and publications, so didn't go very far with it. But I think that's one area that we still could go into farther, and I know in UNAVCO's case they have added some geospatial information into their system. Mike and I have talked about this quite a bit. I know that in the scientific community, the parameter level is sort of where people really want to get to. And again, that's definitely limited by the metadata you have. So either you have that information, or you need to get it, or you don't have it. So,
do you think that NetCDF LD will help that if it actually goes into a NetCDF file and pulls out?
Well, I don't think it's going in and pulling out. I think it's still it's more setting up a structure where you could represent information that's using the semantic web structure. So based on URIs, URLs, identifiers, as opposed to sort of the NetCDF attributes, which are more sort of text-based, I guess. So I think that could be in the future a way to represent the information that could be sort of semanticized, so to speak. But again, so you have to input it. You would have to input it in that way. All right. Okay. Thanks everybody.